Morning, everyone. So I think without further ado, we'll make a start. Firstly, just want to say thank you for everyone who's joined us this morning. Great to see so many names on there. Today is the first of our mini series of webinars, so the Raytec Live Drop-in Sessions. So today's session is EXE versus EXD. We also have two further ones. So the next one is 2 weeks from today. And the final one 2 weeks after that. So if you signed up for this one, you'll get notifications on those two as well. So hopefully you find today useful, and we'll see you again at the other two over the rest of July and August. So again, thanks for joining us this morning. My name's Callum Ryder. I'm the marketing manager here at Raytec. I'll shortly be handing you over to Dave, who I'll let Dave introduce himself when he speaks, but he'll be taking you through today's topic, EXE versus EXD. Just a few housekeeping rules. The presentation should last within half an hour. Depends how engrossed Dave gets, but yeah, it should last within half an hour, and then there will be a chance for a question and answer session at the end. So you should be able to see a small questions section in the drop down on your GoToWebinar page. So if you want to type in any questions on that as we go, or if you've got any now, feel free to put those in, and we'll cover those at the end. That's my quick introduction, and I'm going to hand you over to Dave, who'll introduce himself and take you through the webinar for today. So Dave, over to you.
Morning, everyone, and thank you, Callum. I shall try to not get too engrossed, but I can't make any promises. So good morning, everyone, and welcome to this webinar and Q&A session. My name is Dave Coulthard, and I'm the European Business Development Manager for Raytec, and I'll be taking you through today's webinar and also helping with some of the Q&A at the end. So without further ado, we'll make a start now. So let's have a quick look at some of the topics that we're going to be covering today. We'll make a start with an overview of the two most common protection methods and the ones which we are focusing on today, namely EXE and EXD. Then we'll go on to look at how the choice of these protection methods impacts the end user and how easy it is to install, maintain, and meet the required specification of your luminaire. And finally, we'll have a Q&A session, as Callum alluded to. So if you have any questions as we go along, please simply type them into the questions tab, which is usually on the right-hand side of the screen with GoToWebinar, and we will try our best to answer them all today. So before we look at the two protection methods, EXE and EXD, in a little more detail, first we need to understand why certification is important and why it needs to be considered when specifying an EX luminaire. So once the site location has been identified as a hazardous area and classified into its appropriate zones, it's critical that any equipment which is installed, which luminaires fall into, is compliant with the classification and is suitable for the environment. This includes the top level certification, i.e. the zone, but also for other criteria such as temperature T ratings or gas groups suitable for ignition risks that are present. Failure to select an appropriate luminaire could result in catastrophic consequences, which I'm sure everybody is aware of. The other and less obvious consideration is how the certification can affect the design of the luminaire. Different luminaires can all be certified to the same EX rating, so you can have lots of Zone 1 luminaires, but they may use several different protection methods in order to do this. This means luminaires can be designed in many different ways, which can lead to very different designs between manufacturers and even between models within the same manufacturer. So it naturally follows that these different designs have different impacts on the end user. In these sometimes subtle differences and the impact of them, which we want to hopefully explain today using two of the most common protection methods, EXE and EXD. To understand these protection methods a little better, we need to step back a level to why we actually need EX certified equipment. So I'm sure most of you are familiar with this explosion triangle. which in simple terms states that for an explosion to occur, the following three elements must be present: an ignition source, fuel, combustible gas, vapor, mist or dust, and oxygen. Explosions can be prevented by removing or suppressing one or two of these three elements. The presence of combustible substances is often unavoidable in the operational processes. So if you're drilling for oil, there's going to be oil present. So it's rare that that can be removed. And also because in most cases people are present, it's impractical to remove oxygen. After all, people need oxygen to breathe. So the most practical and more or less the only method is to remove or eliminate the source of ignition. So let's move on to the protection methods now, and we will start with EXE. This is officially known as increased safety, so that may be more familiar. The EXE protection method, the focus of it is to prevent rather than contain an explosion from occurring by ensuring an ignition source, i.e. a spark, does not or cannot arise. To do this, the luminaire is designed to be cool running. Now, I had lots of jokes here about a certain Jamaican bobsleigh team, but on the team's advice, I'll move on and not go with them. And this method of protection is focused on preventing any arcs, sparks, or hotspots from occurring. So by removing the ignition source, the third leg of the explosion triangle, an explosion cannot happen. Now let's talk a little bit about the other protection method that we'll be covering today, EXD. The EXD protection is commonly referred to as flameproof. In contrast to the EXE luminaire, which is designed to prevent an ignition source from occurring, this protection method is focused on containment and to contain the explosion within the housing of the luminaire so it cannot escape into the hazardous environment outside. And to contain the explosion, the EXD containment method is purely mechanical. So by that we mean it's the strength of the housing and the installation and maintenance of the functional flame paths that are used to avoid the flame propagating or escaping from the enclosure. So when comparing EXE and EXD, it's important to say that they are both designed to ensure an explosion does not occur, but one does it via prevention and the other does it via containment. Now, here's where Callum, my glamorous assistant, will take over briefly with a quick poll for you guys. Callum, over to you.
Yeah, so I've just got a quick poll, which will hopefully appear on your screen now. So I think before we go into what the benefits are of either protection methods, you just want to try and understand if people have a preference on EXE or EXD luminaires at the moment. So the poll should be on your screen. So if you want to add your answer in, say whether you have a preference on specifying EXE luminaires, preference on specifying EXD luminaires, or if you have no preference at all. So I'll leave these on for a little while, so you'll have a few seconds if you want to get your answers in.
Yeah,
just around half the people have so far.
It's an anonymous poll as well, so we'll only end up with a percentage, but we won't know who's voted for what.
That's right. And then we'll unveil these answers at the end when we do the Q&A. So if you want to get your answers in now, and then we'll look at the results of the poll when we come to the Q&A at the end. So I think the majority have voted now. I'm just going to give it 5 more seconds. So if you've got any late answers, please get them in. And we'll call that. So I'm going to close the poll now and hand you back to Dave. And then, as I said, we'll look at these answers at the end.
So thank you for that, Callum. And as you can imagine, developing a luminaire to be certified using either of these protection methods means it has to be designed in very different ways, using very different features and different components in order to do so. So the rest of the presentation will therefore focus on these design differences and also how they can impact the end user. So today we'll focus on 3 main areas where this impact occurs, namely installation, maintenance, and meeting the specification. So other things which are affected, such as the gas groups or the temperature ratings of the luminaire. Because the EXD luminaire must be capable of containing the explosion and the high levels of pressure which accompanies it, the housing needs to be suitably thick, often twice as thick compared to an EXE luminaire or an EXE product. This means EXD luminaires tend to be much bigger, bulkier, and heavier to install than a comparable EXE luminaire. They may therefore require extra resource during installation, more operators, or the use of specialist equipment. In contrast, an EXE luminaire is preventing and not containing. While it still needs to be designed using durable materials, which are capable of withstanding the environment and the challenges that come with it, they can be designed to be much more lightweight and user-friendly from an installation perspective. More lightweight, more compact for applications where space is confined and hence easier to install. If you compare a Spartan luminaire to a typical EXD luminaire, they are both constructed of aluminium, so have the same marine grade properties and durability. But the removal of the design and manufacturing constraints from EXD to EXE means they are lighter and encompass more modern manufacturing methods. So moving on to maintenance now. In order to extinguish the explosion so it cannot escape into the environment, an EXD luminaire is designed using functional flame paths. The flame path is the most critical part of an EXD enclosure. While different types of flame paths exist, generally in luminaires they tend to use a high number of bolts which are set to specific torque settings and need to be maintained, and you need to maintain an exact gap between them. Failure to do this can result in disaster. So these bolts must be removed and carefully refitted during any maintenance procedures where access to internal components such as drivers or emergency batteries is required. The person carrying out the maintenance also needs to be very careful about not damaging the flame paths, i.e. when removing old gaskets or when putting covers back on. It may also be advised to use grease between the flame paths to protect against corrosion, while also being careful to use the right grease, usually non-hardening, but you should always consult the manufacturer's instructions for what grease is required. So in short, the presence of flame paths makes maintenance much more complex, with lots of different factors to consider. Now, in contrast, an EXE luminaire does not require flame paths. So what this means is access to internal components can be made much easier. And it's important to stress can, because although it can be much easier, it's not always necessarily the case. It very much depends how the manufacturer has designed the luminaire and how much importance they have placed on designing an EXE luminaire which is easy to maintain. So what do we mean by this? So the generally accepted method to design an EXE product is to encapsulate or pot any areas or components which may pose an ignition risk, thus rendering them safe if an electronic failure should occur. Most manufacturers, even of EXE luminaires, encapsulate the unit as a whole in a method which means it's sealed for life. Now, at Raytec, we do things a little different. We design the luminaires to be modular and so encapsulate the modular components or parts individually. This means that they can be removed and replaced in the future if the need arises. So they are not sealed for life, and things like batteries, power supplies, and even the LED assemblies themselves can be maintained and replaced in the future. So what we can say is that from a certification perspective, without flame paths, there are not the same number of bolts required, so access to internal components can be much easier and much less time consuming. So we've considered installation and we've considered maintenance. An easier installation and easier maintenance ultimately results in one thing: lower long-term costs. A luminaire which is easier to maintain and install requires less resource from the end user and helps to reduce downtime on site. As well as installation and maintenance, the protection method used can also restrict the specification in certain areas. So this includes things like temperature ratings. And what we mean by that is, due to changes in the property of a gas or a vapor at low temperatures, many EXD luminaires are not suitable for areas below -20. EXE is likely to have a much wider temperature rating due to the design and lack of flame paths. So as an example, Raytec Spartan flood luminaire is rated -50 to +55. So you have a big range there. The next restriction can be on gas groups. So only a limited number of EXD fittings are certified to 2C gas groups. Now the problem here that manufacturers have is that 2C gas groups require much tighter flame gaps because they are deemed to be the highest risk gases, which means as a manufacturer, those products are significantly more expensive to manufacture, so tend to be avoided. Finally, we'll talk about wireless technology. So although the hazardous area lighting industry is a late adopter, I would say, of technology, it is starting to catch up. And the thickness of an EXD luminaire is problematic for anybody looking at wireless technology. There is significantly more scope with an EXE certified luminaire. Now, this isn't used wide scale at the moment, as mentioned, but is something which will become more prevalent in the future. So I know that we've covered a lot in those few slides. So let me just summarize some of the main points and benefits of an EXE luminaire. Firstly, easier to install and maintain due to reduction in weight and removal of flame paths, which means you reduce the long-term costs as a result. So if you look at the cost of your luminaire over 5, 10, 15 years, an EXE luminaire should become very cost effective. Specification and functionality tends to be greater based on a wider operating temperature and a larger range of gas groups. And finally, they are more open to current and future wireless technologies. So, thanks everyone who stuck with us through that. I hope you found it worthwhile. Now we'll move on to a Q&A. And unfortunately, I've been advised we will be switching on our webcams for the Q&A, so you will have to look at our faces. But thank you everyone for listening.
We'll put those on now, so you can put a face to the voice. So hopefully you can see us on there. So before we go into the questions, obviously we did the poll earlier on during the presentation, so I'll quickly run that poll now and show you the results of that. So hopefully this pops up on your screen so you can see it. So I think the results from that were quite interesting. So 42% of you said this, you have a preference for EXE luminaires, which is quite a bit more than EXD. So compared to 13% there, but I think quite interestingly, 46% of that came back and said you had no preference. So I think hopefully the benefits which Dave's taken you through on EXE means that for those of you who said no preference, then that'll give you an understanding of what those benefits are and why it's important to look at the certification. So maybe next time when you specify in EX luminaire, then have a look at those, have a look at that certification and the protection method that the luminaire uses, and consider how that might affect things like maintenance, installation, some of the other specification things that Dave mentioned as well. So now is the time for any questions that you've got. So I don't think we've had any yet, so we'll leave that open for any questions. So please get those in. Again, it's just the questions section, questions tab, which will be a little drop down on the on the GoToWebinar panel. There is one here from Gavin. So Gavin asks, Gavin asks, why do I need a modular luminaire? Why do I need a modular luminaire if the L70 data is lifetime over 100,000 hours?
Oh, it's a very good question. So as I understand it, the L70 data is based solely on the lifetime of the LEDs at a set or lower ambient and doesn't take into effect system life. Now we know as technology has moved on over the last 2 years, 5 years, 10 years, that L70 and LED life is huge. Sometimes you can get 150,000 hours, but in reality, the LEDs aren't the weak point of a luminaire. The weak point of a luminaire are the other components. So electrical components, electronic components, batteries tend to be your failure modes. And as an example, electrolytic capacitors in power supplies, they don't last forever. So if a PSU or driver fails in the field, the user needs to quickly and easily fix the issue to get a light back up and running. Then they want a modular fitting where they can swap out a power supply or swap out a battery. Whereas with a sealed for life fitting, if you're operating offshore, you could be without light for a prolonged period and you could suffer failures during this time period. So I guess it's down to ease for the end user, but also, you know, we don't talk about it readily, but say a fitting fails in 4 or 5 years and it's covered by a manufacturer's warranty. You still have a failed unit. You then have to send that unit back to the manufacturer. You then have to have the manufacturer assess it and work out if it was your fault or their fault. And then if you're lucky, you get a replacement sent out to site. So you have a lot of downtime there. And you also have a lot of hassle and a lot of cost, because often you bear the cost of returning things to the manufacturer. If you have a modular fitting where a power supply or something should fail, because in reality, you know, these are harsh environments, these are high temperatures, low temperatures, things do fail. Then with the modular fitting, you can have a unit up and running very quickly, reducing downtime and ultimately reducing cost. I don't know if anyone else wants to add anything to that.
Yeah, just to add something to that one. So as you've gone through there, Dave, the EXD fittings generally are more difficult to maintain. So if you do, for whatever reason, need to replace the power supply in a flame-proof product, then you have to remove all those screws, go into the product, make sure that you're not damaging any flame paths, replace the PSU, and then crucially, you have to put it back together to the manufacturer's specification. So you have to torque all those bolts off to exactly the right torque. You have to make sure that any flame paths are properly greased and maintained. So yeah, EXE is a much more easy fitting to maintain, and that modularity just makes sure that if something does go wrong, you can easily repair it on site.
Great, thanks very much. Hopefully that answers your question, Gavin. Next one here from Igo. In which case is it reasonable to use an EXD fixture? I'm sure he wants to take that.
I'll take that. It's never unreasonable to use an EXD fixture. It's purely down to the specification and the end user. So if you have a specification that's a 2C, it's unlikely you would have an EXD. If you have a specification that's a very low temperature requirement, it's unlikely that you would use an EXD. It's not impossible. There are, you know, we'll be honest, there are fittings out there that go to minus temperatures. They just need to be slightly bigger and bulkier and managed slightly better. But if you have the option of an EXD over an EXE, it's almost like saying, wow, well, you have an option of a fluorescent over an LED. You have an older technology based on containment, which results from prior to LEDs were invented, to now more modern EXE fitting, which will be lighter, easier to maintain, and overall a benefit. But there will be instances where EXD will be a perfectly suitable option. It's solely down to the end user and where they see the benefits lie in each.
Yeah, as Dave says, both are valid protection concepts. There's benefits in EXE over EXD, but if you have the choice of one or the other, I would personally go EXE, but there's still a valid argument for installing an EXD fitting.
Yeah,
thanks both.
It's almost you know, it's almost a similar argument to, well, why should I move to an LED fitting from a non-LED fitting? A non-LED fitting is still certified, it's still perfectly valid. In some instances, the savings aren't as gigantic, depending on the wattage and the size of the fitting, but in reality, you should be moving forward and choosing an LED fitting, and in reality, in most instances, an EXE fitting would be beneficial for the end user over an EXD fitting. Not in all circumstances, but certainly in most.
Great, thanks very much. Next question is from Marcel. Is an EXD fitting always a sealed for life product?
Is an EXD fitting always sealed for life?
Yeah. So I think the point, Dave, you were making earlier is that a lot of EXE fittings are actually sealed for life, using that encapsulation method.
Yep. So not all EXD fittings are sealed for life, but the maintenance, repair, and replacement of them is significantly more complicated and complex than a modular EXE fitting. So you could have an EXD fitting that is sealed for life. You could also have an EXE fitting that is sealed for life. If the manufacturer has decided not to make it open, not to make it maintainable and serviceable for the end user, that's a perfectly valid thing for them to do. But the main difference we're trying to stress is that an EXD product is difficult to maintain, and a modular EXE fitting is significantly easier to maintain.
Yeah, I mean, as part of the inspection regimes for EXD fittings do mean you do have to go in and inspect those flame paths every now and then, make sure that, and part of the requirement for EXD is that the flame paths, the flanges aren't painted. So as Dave alluded to protect against corrosion, sometimes you have to apply grease in there, and you have to go in there, reapply the grease, inspect the flange for the flame path, and so for that reason, EXDs are rarely sealed for life. They're always, you have to go in there and inspect them every now and then.
Yeah, and I recently, so 2 or 3 weeks ago, I watched a webinar. I attended a webinar online, and there was about 100 people who were taking part. And one of the questions asked was, if you scratch a flame path, can you put the unit back together? And these were engineers, these were guys in the field who were on the webinar, and there was a lot of debate and confusion among the guys over what's an acceptable scratch, what's not an acceptable scratch, what's good practice, what's bad practice. So, you know, these guys deal with it every day, and if that's a tricky thing for them to work out, then for a layman like me, it's nigh on impossible. So for me, if you can remove that element and mean that no longer becomes an issue, ultimately, you know, you'll result in potentially better safety.
Great, thanks both. I hope that answers your question, Marcel. The next one, I think, is more of a comment really from David. EX inspections required every 3 years, I believe. Reduced maintenance of EXE is a big advantage. That's certainly something that we would agree with. Any other comments on that?
Yeah.
Just as we've covered, really. So yeah, as we've talked about, EX inspections are required every 3 years, and if you've got an EXD fitting, it just takes you longer, it's more expensive, it's more difficult.
Great. And then I think the last one, which was actually a pre-asked question, we don't have a name against this one, but the question was, why do so many manufacturers still use EXD when EXE is now available?
So I come across this a lot in Europe, and there's a tendency to specify what you've always known. and work with what you've always worked with. So many tenders and specifications have EXD on because the guys have always used EXD, and it's what they know and it's what they're comfortable with. There's also a perception that to contain an explosion is safer than to prevent an explosion. So even if something goes wrong, my EXD will protect me because it'll contain anything that's gone wrong. Now, there may be an argument for that, but only if you maintain the fitting perfectly, if you do all the routine maintenance, keep the flame paths, and EXE fittings by preventing any ignition are equally as safe. But one of the big things, and it's sort of an open industry secret, is that a lot of manufacturers have used EXD. A lot of manufacturers have access, or part of their business is actually casting these parts. So they own companies that cast these big heavy EXD enclosures and big heavy EXD parts. And when they've upgraded to LED, the cost and the investment required to change from an EXD to an EXE fitting, you know, the tooling on a new product can be upwards of £500,000. So they tend to upgrade an EXD non-LED fitting to an EXD LED fitting, and what you get as a result is something that's sort of halfway in between.
Okay, Steve.
Yeah, just as Dave says, I mean, generally speaking, the upfront investment for a manufacturer who wants to make an EX fitting is generally lower if they go down the route of EXD, so flame proof. You do need a big heavy casting, but generally the manufacturing techniques to make that casting require a lower investment. And generally for EXE, you need to invest in methods of encapsulation and high pressure die cast tooling. So generally speaking, investment for a manufacturer in an EXE fitting is higher than EXD, which is probably fundamentally why some manufacturers choose to go down the route of EXD.
Yeah, and also you'll find that people follow the path of least resistance, and they know what they know and they like what they like, and they don't know what they don't know. So if they need to replace some fittings, they'll often look at the fittings they have in place, look at the specification, look at what the nameplate says, and then stick that on the request and say we need this as a replacement.
Yeah. Great. Thank you both. And then one more from Mohammed. What about lifetime for EXD and EXE? So I presume Mohammed's talking about the lifetime of the luminaire as a whole there.
Yep.
Generally speaking, I think you can have similar lifetimes for both types of fitting. They can be made from the same grades of aluminium. They can have the same components within. They just have a different protection concept. So there are ways of making both types of product have the same lifetime. As we talked about, generally, well, the standards require that an EXD flame path is not painted, so it can be more susceptible to corrosion for EXD. So that would probably be the biggest factor, is the corrosion.
Yeah, and it also, my understanding is that they are monitored and certified slightly differently. So an EXD based on temperature will be based on an external temperature. An EXE is always monitored based on its internal temperature. And anyone that manufactures an EXE fitting and we pot or encapsulate any of the critical components, when you imagine a control board or a switch mode or a ballast, as people may know them, you always have hot spots. So you'll have capacitors and other parts that get very hot, and you'll have other components that get very cool. What electronics don't like is hot spots. So what tends to happen is, or what does happen is that when you pot that, you reduce the temperature to an average temperature. So you reduce some of the hot spots and you bring up some of the cooler temperatures. And what that means is that you can get longer lifespans out of those components.
Okay, great. Thank you both. So that's all the questions that we've they've received for now. So I think we will hang on for a little while. If there are any more questions, please send them through and we'll do our best to answer. But in the meantime, just want to say thank you very much again for everyone who's been on. We'll be running the session again if anyone wants to have another run through this afternoon at 4 p.m. UK time. And like I said, this is a mini series of webinars, so we'll have 2 more topics over the next few weeks. So if you've signed up for this one, you should receive the notifications for those 2. So please watch out for them. We'll hopefully see you again in the future ones in the coming weeks. So I think we'll turn our webcams off now. But like I say, we'll hold on for a little while. So if there are any more questions, we'll be here for a little bit. But thank you very much again for attending, and hopefully see you again on the future ones. Thanks very much.
Thank you.
Thank you.